Hello, all, and welcome to our June Data Science Code Pudding stream. My name is Tiffany Hall. I'm an alumni of TripleTen Software Engineering Program, a full stack engineer, and a product owner at Scholastic Inc., the world's largest publisher of children's books and a powerhouse in the digital education space, too. Tonight, I'm very excited because I get to be a host of our June Code Pudding, and which is featuring the DS team, the data science teams. I'm so glad that you guys could join us at home and watch as you see all of the hard work that our students have been putting in over the last week. These code jams, as many of you know, are some of my favorite ways for a lot of our students to get together and form those kind of remote work bonds that they're going to need so desperately and while they're students and when they're working. But you may be asking yourself the question, like, what is a code jam and what is a code pudding? So, since you might be asking yourself that question, I would be happy to share. So, our code jams and code puddings are our friendly competitions here at TripleTen, where we get our students together and it occurs during their normal coursework. They're very short competitions. These competitions are days, 5, 6 days at the max. And so our students are divided into teams and then they start putting in the work on the data prompts that we've given them and all of the data sets that we've given them too. Our code puddings consist of two parts, working with the data and building up a model and a presentation. So last week, our participants were divided into their teams and they were challenged to collaboratively build an interactive data dashboard that explores music trends using the data sets we've provided them. Some of them have even been Spotify song data, so many of you might have contributed. Our teams had 5 days on this one to put in the work for their projects, and they're going to show off all of that hard work today to you. So then next week, our judges are going to review all of their work and their dashboards and evaluate on their models and presentation. All of our results will be posted on Discord and socials June 12th. And if you are watching at home on as a student, you can vote for your favorite project as an audience award nominee so that it will be in the Discord channel. And then if you're not a student of ours just yet and you're watching on YouTube, you can vote in the live chat below this, or if you're watching it back on repeat, you can vote in the comments section. All you have to do to vote for your favorite team is write on the name of your favorite team. Very simple. Easier than the elections. All right. Tonight is time for us to get started on our presentation. We have 3 teams with us tonight, and I'm so excited. They have the best names, so I'm very much looking forward to them. Tonight, our first participant group is going to be the Melody Metrics. And this team consists of Victor Klufinski, Eli Adams, Sohini Tamar, and Giovanni G. Take it away, Melody Metrics.
Okay. You ready?
Looks good. Go for it.
Sahini?
Hi, everyone. We are Melody Metrics. We worked on our song data sets, and you will see our analysis right now. Our team is Eli Adams, Sohini Tomar, Victor Klufinski, and Giovanni G. Victor is a student, and all of others are graduates of TripleTen. Now I'll invite Victor so that he can take over the floor.
Hello guys, my name is Victor and I'm going to tell you today about our interactive data project. So our main idea was to make the project that explores Spotify song features and popularity patterns using Plotly Dash to visualize insights and help users discover music recommendations. So for the steps, we did clean and analyze the data, apply k-means clustering, retrieve audio previews via API, and develop interactive dashboards. And also, I can say about correlation metrics of musical features. So the main of them is energy features, valence features, and popularity features.
Thank you so much, Victor. So let's talk about k-mean clustering. It was our bonus question. So clustering, we divided our cluster in 4 clusters because when I did elbow method, I found out 4 will be the optimal number. So the different cluster signifies different features and their ability. So if you see cluster 0, it is high on liveliness, which is the live audience or live element is higher. Cluster 1 is high on popularity. Cluster 2 is moderate popularity. Cluster 3 is highly acoustic. On the right-hand side, if you see that bar graph, you can see that visual representation so that you can see cluster 3 is high on liveliness and cluster 0, you can see it's high on acoustic. If you see at the bottom, you see that multiple colored dots you see. That means different songs for different artists, they fall on different clusters. If you see on the right side of the screen, you see Snap, and most of the song belongs to cluster 1, which means they are popular hit, high in popularity. On the other hand, if you see Elvis Presley, bunch of song falls in different cluster because you see those multicolored dots. So we can say he has diverse panel of his songs and everything. We also have Billy Joel. You can see some blue dots that represent cluster 0, which is highly live. Next slide, please. If you see here, there is a snapshot of clusters which we created, and you can see different features up there. Eli will talk in the Plotly Dash where he will explain this more in details. But on the right side of the screen, you can see Poker Face and D-Bomb. They have similar kind of energy level and danceability. That's why even though they are in different genre, they will fall on the same cluster. And if you look at Bridge Over Troubled Water and Once Upon a Time, they fall on similar cluster, even though they are in different genre, just because their features are very similar. Their song vibes match. At the bottom, if you see cluster centers, the acousticness you can see by the data, which we did. This is a code snippet of our project. In cluster 0, acousticness is 70. That means it's closer to 100. It is high. And if you look at liveliness, cluster 3, you see 67, which means it's high on liveliness. I will pass it on to Giovanni. Chi?
All right, thank you, Sohini. As a bonus, we were tasked with integrating audio previews into the dashboard. These audio previews were extracted and integrated using Labrosa and the Deezer API. Labrosa is a Python library that offers a wide range of audio features for analysis and extraction. Spotify has made changes to its web API as of November 2024 that affect how developers can access and use 30-second preview URLs. This means that developers will likely find that the preview URL will return null if you try to extract that data. But fortunately, the Deezer API is an alternative that allows developers to integrate Deezer's music library into their applications and websites. And this is the script that defines the function. Oh, sorry. Yeah, this is the script that defines the function, which processes the data set, fetches audio preview URLs using the Deezer API, downloads 30-second previews, and plays a specific song using the Labrosa Python library. So overall, this script automates fetching, downloading, and playing previews of popular songs. And I'm going to pass it on to Eli to go over the dashboard.
Okay, first of all, here is the link to the dashboard right here. And it might take a bit to load on your own device because it is the free version, just letting you know. And here it is. So right here you could see Sohini's work. She brought together the clusters. It's 0, 1, 2, and 3, but we named them based on the features that they have. You can see the different ones here. So this one is for acoustic mainstream. It's more popular, there's more acousticness, and there's more danceability, but you could change it based on what you wanted. Here's the top 10 songs for the acoustic mainstream, and you can listen to them.
gotta wait. I'm your
based on what you want to be looking at. And you can keep going through all of there. All 2,000 songs are available for preview and to be able to look at and see their popularity. Now onto the analysis. If you were looking for a specific genre, there's so many. Like I didn't know Dutch cabaret existed. Maybe you didn't either. But there's also a bunch like Dutch prog, Baroque pop, but album rock takes up a lot more than any of the other genres. The rest of it is based on whatever you choose here. So you can select a specific genre, like if you want acoustic pop, you can see different songs that take over acoustic pop. And you can see like, oh, this guy, he makes the most acoustic pop songs. They're not really, acoustic pop isn't really a good danceable song. But like if you did acousticness, because it's acoustic, there's more songs for acousticness. And different amount of songs are made throughout the years for that. But if you do a more popular one, like adult standards, you can see it's between like 60 and 80 popularity score, which seen here, that means they're very popular songs. So you could see that throughout here, it changes more. So Elvis Presley now he makes more adult standards. Well, he made more, and he has more adult standard songs than anyone else in Spotify. And if you were looking for specifically adult standards and you wanted like a good song for like a party, you do danceability and energy. You can look over here. I wish. Okay. So these would be good songs for like a party if you wanted that kind of genre of music. And yeah, you can keep looking through here to the next songs, change through if you want to look for something more specific, but there are a lot of songs to go through. And based on this project, you could see that we performed data analysis. We got all the features we needed before clustering. Then we moved on to unsupervised learning to get k-means clustering to group them in the categories. And then we did audio integration to get all the audio in and all of that figured out. And we put it all together into one dashboard. And that's our project.
All right, that is fantastic. I know that you guys couldn't see at home, but when they played the live previews, I was kind of geeking out quite a bit. So let's talk about how all of this fun, like magical goodness got into the project. So first things first, great project, really liked it. Let's talk about the question that I think a lot of people want to know is like, when you're going through the process of taking all of these data sets that we give you and you're cleaning them, how do you then figure out what that story you're going to tell is?
Well, looking through all of the features, we got it all from Kaggle, the one that was offered. And pretty right off the bat, like there wasn't really any cleaning necessary. It was already a really well-made data set.
Oh, that's great. It really saves a lot of time.
Yeah.
So then in terms of like separating out all of the pieces, they kind of just rise to the top for you guys, right? Like you were showing with the Baroque pop or the prog rock, like all of these music genres I didn't know existed.
Yeah, there's a lot.
So in working together, I know that many of you guys are graduates, but now that you are looking back on the second iteration of trying out these code puddings, how do you feel like the first time versus second time is going for you?
Less nervous. I was freaking out the first time when I came in, and when they gave me the project, I was like, oh my God, it is so different when I was doing the actual studies. Now you have to put it together, and I was kind of lost. But thank God to my team members. As always, this team was amazing too. I couldn't figure out Plotly Dash. My computer was not acting up properly. It was technical. Server was not connecting somehow. But Eli was there to figure it out. He's like, I'm having too much fun. So it
was a lot of fun to make.
Yes. So I was like, thank God you're having fun because my computer doesn't act up. But yes, but then later on figured it out. I was like, I have to make it work. So it worked. But yeah.
Victor, now how are you doing? You're not the graduate yet, just not yet. It's getting closer, but it's definitely your second time as well. How was it for you?
Yeah, so it was my second project, but I was still worried about like how I can help my team to make this project like look much better, how I can help my team. So I was still worried about all this.
And so, were you able to find different ways for you to bring value, even though you're just a lowly student still?
Yeah, I know that I'm still learning like all of this data science stuff, but I think our team was probably the most like useful for this project. We're just working together and just we were trying to connect like to make this project like very very nice.
If I
Very
just
cool.
may add, he did all the analysis and all that stuff.
Yeah, I was
Victor's
trying
over
to
here
help.
acting like he just phoned it in.
Yeah.
So you said earlier
They,
that the audience wasn't able to hear the audio. Were you guys not able to hear the audio?
no, we heard it.
Oh,
Yeah,
okay, good.
yeah, they
Oh
heard
yeah,
Sorry
it.
about
yeah,
that.
totally. It was a moment of definitely like jaw dropping for me.
We could hear that.
Yeah, you're good to go there.
Sweet.
So you guys were able to even hit one of the bonus kind of prompts so what made, like, what do you think made this, I don't want to say so easy. How did you guys, what do you attribute your success of being able to complete the main portion of the requirements so fast that you were able to get to one of the bonus pieces?
Well,
Do you,
most of us are graduates, so we each
So
did
that
one
helps.
thing. So like I did the dashboard, Sahini did the clustering, Giovanni did the audio, and Victor did the analysis. So we had just everything was covered.
Sweet. All
Yeah,
I'm
right.
and
already working
sorry
on a
to
project that's very similar to the dashboard, so I already knew how to do most of it.
yeah, and to piggyback on that, the last code putting I did was coincidentally like a Spotify music project. So that bonus task, I already knew how to do it. So that was
Like,
kind
this is
of
old
lucky.
news. I got it.
Yeah, I was like, so-
This was a lot
Yeah.
different than other code jams though, because
Oh,
most of
yeah.
them are with like a predictive model and making something, and this one was completely different.
Yeah. Daniel, who is our tutor and mentor for our data science students, he likes to really change it up and stay ahead of the curve when it comes to just new tech that's out there and different things to try and do. And it's one of the most exciting parts for me is to see what you guys come up with.
Mhm.
Yeah. All right, that is Melody Metrics, and really congratulations, really great job. That team consists of Victor Klufinski, Eli Adams, Sahini Tamar, and Giovanni Jean. Okay, we're going to go to our next team. Our next team is the Beat Seekers. Beat Seekers is going to consist of Eric McDougall, Kristen Alston, Julia Perino, and Josh Oleemi.
Hi, everyone. I am going to be sharing my screen. Let's start it. 1 second. I trust that everybody's able to see the screen.
Perfect, yes.
Okay.
Thank you to everyone for coming. We're our team beat seekers on this project to explore for Spotify. Our team members that got mentioned, Eric McDougall, Crystal Alston, Joshua Oliemi, and myself, Julia Perino. We're going to go through the goals we identified, some of the work we did to prepare for the modeling, and then the showcase of our dashboard. One thing we looked at through the data was provided there were so many features. Each song got ranked on like energy, loudness, and each genre. So one thing we engineered to compare all of these things together was about the moodiness. We did that intersection of energy, danceability, and how much speechiness is in a song. And we use PCA analysis, which really identifies the directions that each of these features went in and where the data varies the most, and then connects those features, combining them into axes which represent shared patterns or trends. And so it was able to give a numeric result of how moody each song would be. My bad. And then we moved on to some data prep, getting ready. One thing that we noticed is just how the features were related to each other in general. You can see here a heat map along the X and Y axis. See features present in each song. The calculation on the chart shows that it increases towards the red is how similar things have become. Overall, there's not a lot of correlation between these features, but the highest one observed was between loudness and energy, which really makes sense because the louder the song, the more energy you have to dance. Also, as we were evaluating, the data had more than 140 different genres. So what we did was convert the genre text into TF-IDF vectors and used those k-means clusters to see where the genre names overlap to create these broader categories. So we can see on the left, it went from more than 140 different categories into these major categories on the right, like dance rock, classic rock, glam rock, all got merged into that rock group. The pop ended up having a higher frequency because it included genres like Dutch cabaret, which we touched on as being amazing, and then American hip hop. Here we can see some results of that moodiness score that we created. It really varied between the least moody song being rated as Louis Armstrong's Summertime at -2, and then the moodiest song being Youngblood by 5SOS. And now Joshua is going to talk a little bit about the modeling he performed.
Hello, everyone. My name is Joshua Limey, and I was in charge of the modeling aspects of our project. So, how we kind of wanted to approach this was that we wanted to we decided that to instead of trying to predict all the genres. We picked the top 10 genres and then we made a numeric column based off of different features like year, beats per minute, energy, danceability, loudness, liveness, valence, length, acoustics, speech, popularity, and mood score. And one of the biggest things that we also wanted to take into consideration was the class imbalance because though we did pick the top 10 genres, album rock had way more data entries compared to any other genre. So we didn't want the models to just overly focus on seeing album rock, and we wanted to make sure that all the features and all the classes were weighed the same. So smooth was added mainly for the gradient boost, and we made sure to scale the data as well too, so that each model would view all the features the same. So BPM or wouldn't be higher or considered higher than like energy or valence or whatever the case may be. So moving forward to the next slide, we showing the results of our data. As you can see, the things we were looking for was how long does it take for the models to be trained? How accurate are they? What is the F1 score? What is the OPROC score meaning? And mainly the OPROC score is what we're looking at because for our models, we want us to be able to have them predict what song is in which genre. So out of all the ones that we ran, we decided that random forest was the best model, and that was because one of the biggest things was that it had the third fastest training time, and it had the highest rock score out of all 5 of the models. So we decided that moving forward with that Plotly Dash, that random forest was going to be the model we used to predict songs into each genre.
Hi, everyone. My name is Crystal Austin, and I was in charge of handling the Plotly Dash for our project. So what we focused on for our dashboard was visualizing the model results, mood over time, and then doing an audio feature of the top 3 songs based off of their popularity. So Plotly Dash is a interactive dashboard that uses Python to combine interactive visualizations, show dashboard components, and it essentially gives users the ability to see the data in an interactive form that makes it like really fun and creative. So as I said, we wanted to visualize the trends of across different genres and their moods, allow users to explore and compare the model performance that we used, and also provide that interactive audio player. And so, as previously mentioned, one of the issues that we ran across was that Spotify changed the way that you are able to use audio previews. They deprecated their preview URL function. So what we did for our project was we did an audio embed. I used our data set to determine the top 3 most popular songs. And that's what you're seeing in the code here. I took those songs based off of their title, artist, and their Spotify ID, and I placed them into an embed code so they would appear properly on the dashboard. And so I am going to switch over to our dashboard so you are able to see everything. And make sure this is out of the way. So in this first section, you'll see the model performance and a prediction function. You are able to see each model that we tested and their corresponding metrics, the accuracy F1 score and the OCROC score. As you can see here, random forest performed the best, and there you are able to hover over it and see each variable and its corresponding metric. We did use random forest for our predict function, in which we use songs from the data set to run through the model without, of course, like the target feature being the genre, to see if it's able to predict the correct genre. So all the songs in the data set are here, and I'll show you a couple. So very first one, Don't Fear the Reaper. The predicted genre is album rock, and the actual genre in the data set is album rock. Show a few different ones. Gonna move this over to the side. So here we are, a little less conversation. The predicted genre is adult standards, and the actual genre is adult standards. So I'm just gonna switch over to our next section. Balance over time or mood over time. And it's gonna take a couple seconds to do that switch. So let's see how fast it wants to work now.
Crystal, while it's updating, can I ask, what is a cat boost classifier?
That's one of the models that we used for doing the testing and the training.
Oh man, I thought it was going to be one of those genres like boots and cats and boots and cats.
No. No, this is just one of the models that we used during our project. So here is the mood of songs over time. We created a animated spectrum of over the years. And we have our top genres here. So not all the genres, just the top ones here. And this function allows it to play. We did run into a bit of a issue with the way that the years were appearing, and we are still kind of playing around with it to try to get it to work properly and go in order, because it kind of like breaks it up into groups. Really odd situation, but nonetheless, like what you can see is that over time, you're seeing an increase in energy and mood of the song. So I think that also goes to show that there is a correlation between like the energy and the mood. So higher energy, higher mood. And this also has the ability to hover over it, where you can see the song title, the associated genre, year, energy, balance, and then the popularity as well. And then for our final section, the embed version of the top 3 most popular songs, you have the ability to listen to previews of each song.
Everything gon' be alright. Gonna raise a glass and say, hey, here's to the ones that we got.
So I don't know about anybody else, but of the top 3 most popular songs in this data set, I would assume that it would be All I Want for Christmas Is You. I wouldn't have assumed it would have been Dance Monkey, but this is the exact order of the top popular songs in the data set. So it had All I Want for Christmas Is You coming in at number 3. And I am just going to switch back to our slides to close us out.
Yeah, so to kind of just give a overall summary. So to kind of answer some of the earlier questions that we had, has music changed over time? It has definitely changed over time. It's increased in energy and it's increased in moodiness. Can you predict songs and what genres it can be in? Yes, you can predict it when you run you use a set certain type of features and put the right parameters and make sure that everything is balanced. And lastly, Plotly Dash was a great way to represent and showcase the predictions, the change in moodiness over time, and even show you previews of songs based off of what we ran in our data sets. Next steps is moving forward, just hypothetically speaking, if we're continuing to do work on this project, is that we would want to update a lot of the data sets, because the latest songs were from 2019 and we're in 2025. So clearly there's been way more songs that have been released from that time period. So we would want to have more representation, because then the models can really have a better grasp of what genres and what styles of genres are in there, because that was the biggest thing that we were noticing when we were looking at the genres, that there was over representation of album rock, and like literally every other genre had like literally there was like 400 plus like data entries of album rock, and every other entry had like around 100 or 200, and some had like 10 or 20. So if you're trying to make a really accurate prediction model, you would want as much representation from different genres as possible, so that it can have a better accurate prediction on what type of genres it can be. So overall, that was kind of just our last thoughts, the overall project that we did.
All right. I'm still kind of stunned that Mama Mariah is letting Dance Monkey be number 1. That doesn't sound right. I feel like she's going to come out swinging over that one. But okay, fine. We'll let that one go for now. The data doesn't lie, right? All right. So let's talk to the group now. Really great presentation. I think that my favorite part is the bouncing balls of energy graph that you guys were able to put together. And it always makes me wonder around the visualizations that you choose. And is this like part of the coursework that you guys have with TripleTen, is like figuring out what is the right visual to go with the right data to make sure you're showing the right thing? Yeah, I guess that's like, how are you guys choosing these?
Well, we kind of went through a few different kind of visuals that we wanted to show. I mean, I can especially speak towards like the Plotly Dash. We originally wanted to show a pie chart kind of showing the percentages of like the like popularity or the moodiness of songs over time. And like we had the ability to include that in our code, but Plotly Dash doesn't allow you to show like an animated like over time spectrum like that scatter plot that we have there shows. So it's kind of like a little bit of like a limitation because we wanted to show that, but then instead we decided to show something a little bit different that allows like that over time animated function to occur. But yeah, I mean, this is stuff that like we're learning, or we have learned in the TripleTen coursework, you know, telling us like what kind of visualizations are best and which visualizations show or tell the best story to the person who's receiving it at the end of the day, because they're not always data scientists.
Same, not a data scientist for sure. So in terms of like the project in the code putting, the process, whatever part of it, I'd love to hear what parts are y'all's favorites to work on.
I will speak for myself. I definitely enjoyed the modeling aspect of the project, just trying to figure out like what are the hyperparameters, the parameters that we needed to implement into the project, making sure like keeping like what are the metrics that I'm looking for, whether it's an F1 score, the Aqua score, or the timing or the accuracy, and making sure to like also understand like what is it that Python is telling me about these models and having to figure out which one is the best based off those different features. Because I mean, if you saw a table, there was a lot of different numbers, and sometimes you can get confused, but it's like learning how to like, okay, pick, okay, this model may have a faster time, but its accuracy is very low, or this one has a longer time, but its accuracy is very high. So which one do you pick over the other? So I honestly really enjoyed that. I thought that was a really, and I just had like finished working on that in just my a previous sprint. So I was just like, this was like a really good opportunity to really practice what I've learned. So I really enjoyed that.
Perfect. I love that. I love when you have a quick moment. I mean, again, as a teacher, I love when you have a moment to like, here's the thing you're going to learn. And now here's an opportunity to practice a real life application where there's little structure, right? And you have to really kind of apply the knowledge there. That just makes my teacher heart happy. What about anyone else? Anyone else have any other favorites? If not, totally okay. If you were like, this sucks, hated it all, just doing it because I want the practice. Understandable.
I always think an enjoyable part of the project is working together. Everybody's communication style is its like own ecosystem on the team. And so I think everyone attacked different parts of the problem. So with such gusto, so it was cool to get to be a part of that.
That is wonderful too. I do love that part. All right. Well, I'm going to go ahead and stop our chat here, because if not, then I'm still going to go back to the Mariah Carey thing. I don't understand how Mariah Carey just isn't number. It doesn't make any sense. You know what? We'll just move on. We'll move on. It'll be fine. We'll just all take a deep breath. Okay, so this has been the Beat Seekers with, with Eric McDougall, Crystal Alston, Julia Porino, and Josh Oliami. Thank you guys so very much. What a great presentation. All right, our last presentation of the evening is Team 24/7, and that is with Ken Klabnik, Gil Fadu, and Tirso Paneke.
Hi, how are you? Let me
Great.
get my screen share. I believe, is it here?
I like they did Zoom and did just redo all of their
There it is.
features there. So
Yep. This looks like the right one.
perfect.
This one, you should see the PowerPoint and not anything else.
Correct.
All right, excellent. Thank you.
Hey,
Jill,
hi.
Tirsa, are you ready?
Yes, I'm ready. Hi, everyone. I'm here to present our team 24/7 and our team's project to develop an interactive music trend dashboard. So before we start going into detail, I would like you guys to introduce my team. So our team consists of 3 members. The first one is myself. I'm a TripleTen DS student, followed by Ken. He's a TripleTen DS graduate, and last
Hi.
it's TripleTen and Tressa, TripleTen DS student. So before we start going into more detail, I would like to go over a project overview. So our project goal was to develop an interactive dashboard using Plotly Dash to visualize and analyze Spotify music listening trends across genres, time, and audio features. For this, we use some key features to demonstrate some good visualization like dynamic charts, genre-based filters, popularity insights, key means clustering to explore some similarities. And using those key features, we had a good outcome. We had a user-friendly web app that empowers users to explore music data dynamically and gain deeper insights into listening patterns. So now let's go to the dataset, now we are going to go over big questions which we are going to answer for this project. So the first question is, are the audio features different for each song that make it popular? How do musical preferences vary across different genres? Are there like kind of clear patterns in energy, danceability, and other metrics over time kind of audio features? Which songs are more similar to each other in terms of musical characteristics? Like if there are two songs with high loudiness, are they like similar? How can we use clustering to reveal hidden structures in the data? So to answer those questions, we will definitely use a data set. So let's review which data set we used and from where did we got. So we used a data set named Spotify Top 2000 Mega Dataset, which we found from Kaggle, and it's publicly available. It includes detailed audio features and metadata from over 2,000 popular songs. Along with this, there are like 15 columns, which the columns included were among audio features, which were danceability, energy, loudiness, speechness, valence, tempo, debracing. These features were quantifying different aspects of song sound. Along with this, we did have like metadata, which were focusing on tracks name, artist, album, release date, and popularity, which also helps us understand that how the time rate changes the audio features. And along with that, lastly, it was columns also included genre classification, which was like pop, hip hop, rock, which was really good because this dataset was kind of detailed and had a reach, which helps us to analyze different trends. So after getting the data set from Kaggle, we did a small EDA, and for pre-processing, we found out there was no duplicates found, there was no missing values found. The column values were converted to lower and snake case, and we did like one tiny kind of feature engineering like for genre group. So kind of there are some kind of rows where one was rock and other one had a different name for genre, but it had like and name was rock. So we end up kind of combining them because there were like some categories we are really underrepresented. And so it is better to just combine them, which is like more understanding to the audience. So after doing an EDA, we kind of did a heat map, which help us understand the correlation between the audio features. Here you guys can see that it indicates which features has high positive and negative correlations with other features. You guys can see from here that most of the audio features, they don't have kind of good correlation, like they have weak correlation, but energy, which is positively correlating with loudiness, while negatively correlating with acousticness. We use this heat map because it helps us to decide what kind of charts we'll be using and we can include in the app. Interestingly, the correlation for popularity, you guys can also see that it has a very weak correlation with all the video features. So to better understand those audio features, we did a polar chart, which Ken is going to explain in the next slide.
Yes. So one of the features that we put on our app, I say features, a feature of the app is a polar chart. Kind of looks like this little radar thing in the screenshot. And we wanted to investigate these features a little further, so we used that to help visualize it. And there were still a few things that we needed to understand better, so I went and looked through the Spotify API because much of it is in there explaining what's going on. Valence was particularly vague. That turned out to be the positivity of the track, so a very sad or angry song would be low valence. Popularity means that the track has been played a lot, especially recently. So for instance, the one that had 100 popularity we were talking about earlier from Tones and I. It's a bit of an outlier because it was being played a whole lot very recently when that data was taken and put into a data set and published. So that's interesting. Energy is a score that largely measures fast, loud, and noisy. So it's sort of a combination of those things. And speechiness, which scores high on tracks that are mostly spoken words. Since most of our data set is music, a lot of it is low on speechiness. Some of it has a little bit. Certain rap and hip hop tracks will have partially spoken and partially sung, you might say. So as we progressed through this app, we had more and more questions, and so we put in quite a few charts. This is, of course, popularity by genre. It's interesting because it doesn't necessarily show which genres are popular overall. What this is this is the mean of how popular each individual song in that genre is, which is a bit of a distinction. So, for instance, those neo-mellow songs, that would include things such as Waiting on the World to Change by John Mayer. And those seem to have the most consistently high popularity among all the examples in our data. Whereas, something maybe more like hip hop or rock, which is a little lower, might be a little less consistent, even though a pop song was the #1 popular track, as you saw in previous presentations. One of the questions that we did want to ask is, are highly danceable songs popular? So danceable songs tend to be high energy, high valence, and have a very consistent tempo. So we made a scatter plot that shows where different tracks fall on these two axes, and they can be filtered by genre. And we also had this energy over time so that you could see tracks by their publication date with different energy, and you can look for specific genres in there as well. As well as we did artists by popularity. You can get the popularity of specific artists, or you can filter by genre. As you can see, both Tones and I and Imagine Dragons were highly popular. Elvis, not so much. Just very funny. Popular tracks, fairly self-explanatory. I will show you this on the app shortly so we can play with that a little bit and just see the genre. We also embedded Spotify previews so that users can hear the music themselves. We implemented this as just a dedicated dropdown for song previews. This did take a bit of a workaround. Spotify's API with regard to the previews has been broken for some time. I won't detail that for the sake of time, but it seemed pretty strange to not have that ability, so we made it work. And then the last major thing we did was k-means clustering. So the k-means clustering, of course, allows you to find songs that are similar to each other on these different metrics. And one fun thing was that we were able to filter the chart by genre, and that allows you to pick out a specific track, but then find tracks in a different genre that have similar properties. So, for instance, it seems like Clint Eastwood by Gorillaz, a hip hop track, is somewhat similar to Pinball Wizard. So, future improvements for the app. Much of what we want to do would involve user authentication. Currently, that is not a requirement to use our web app. And if we did have that, we could connect to the Spotify API and potentially have users be able to add things to our playlist straight from the app, or get more recent data. And of course, the data set could stand to be a little broader too. It only goes to 2019, and there were a lot of genres that had very few examples, which is why we had the genre groups. And so you can try the app for yourself on Render at this URL. I will go ahead and preview that shortly. And that's about it for the PowerPoint. Yeah, can you see this? I want to ensure that this is still sharing.
Yes,
Okay.
we can.
Yeah, interactive music. We're good.
Yeah. Yes, excellent. So this is what our web app looks like. I have it in full screen right now. So here's the polar chart that we saw earlier, and you can click the drop down. Here's metal. You can see the energy went way up over adult standards, and so did the loudness. And if you go to hip hop, you can sort of see a different spread. It's a lot more danceable than metal was, for instance. One thing that didn't make it into the PowerPoint, we have musical airs. So you can sort of check this range, and it will affect the popularity graph. That will show which genres are most popular in that area, and it will also list the most popular song that is within that year range. We have the popularity versus danceability. We showed that one off already. The energy over time. Yep, you can just add whatever genres you like to that library, and it will show you the data for that. And we have our top artists by popularity. Here is sort of the whole thing for that. Here are our popular individual tracks and our preview. So perhaps I want to do some Frank Sinatra. We can do that, and it will pop up with the Spotify preview embed. I'm not sure that the audio will work, but so I'll just hit play for a couple seconds. Yep. And lastly, we have our k-means clustering. And that is about all I have for you. Do we have any questions?
Lots of questions. Really cool. I appreciate you. Can you put the website back on your screen so that way if people
Yes.
at home want
I'm gonna
to
have
try it
to
out, they can?
take this off of full screen.
Okay.
And there we go.
Oh, perfect. I just want to make sure that those who are watching at home get a chance to see it and type it in
Yes.
so they can try.
If YouTube allows me, I'm going to try to put that URL in a comment under the video when it goes up to YouTube. Do note that Render's hosting is free. Sometimes if nobody is using an app, they will spin it down and you'll have to spin it back up, and so it might take a while to load. So
Cool. All right. All right, you can go ahead and stop sharing. Now we'll just ask questions.
Right.
That was really cool.
Thank
I
you.
really appreciate that. So you guys had 3 team members. One had to drop out, which is kind of a bummer, but how did you guys navigate those challenges in real time? Because that can happen. I know at work right now, I've had one person who was out with a toothache. And so, being down at dev for a few days is a big deal, especially when you're trying to work in a week's time.
Yeah, I'm sorry for your coworker.
Well, he'll be okay. He's going to the dentist.
Yeah, Jill or Tirso, do you want to field that question? I have been speaking for a few minutes now.
Yeah, sure. So, when we didn't had any contact from other members, I didn't like kind of stop working because we don't know if they're going to participate or no, not. So when this happens, mostly what I think that they are not going to participate, and I'll be prepared that I need to. In my mind, I'll be prepared that instead of 4 members, we just have kind of 2 right now who are participating, and then we just have to complete by this deadline. So we need to increase our speed, try to keep doing it whatever we can. Like one of our member, they just told us yesterday that they couldn't participate. So me and then other 2 members, they joined us. Like I came right after the work, and we end up sitting like all together. We joined on Discord, communicated that, okay, can you just guys wait for a minute? I'm going to like commit right now. You guys can now git pull. So we all started coming together because everybody was at that time available. So we were working together, trying to complete task by task, trying to fix stuff. We started dividing stuff to everyone so we can get completed and more stuff can be done in sort of less time. So yesterday we completed and it came out pretty good. I was kind of impressed by ourselves how much work we did in like less time. Yesterday, like almost like 5 hours, we did a really good job. And then it just boosted my confidence because before I was thinking that we might not even be able to present. But then here we are presenting and then we did a really good job. So yes, it's just like keeping a positive attitude. By like myself too, I get like upset too, like okay, maybe I cannot compete well with other teams, but then I'll like keep doing like as I did this time too. So we really got a good result. So I think positive attitude and then keep doing your work till the end. Like no matter if even if you cannot complete it, just try your best to complete it. That all it matters. I think, yeah.
I would add to that, we had a little bit of difficulty with time zones as well. I am East Coast United States, Jill is West Coast United States, Tirso is somewhere in the middle. So coordinating schedules was not always the easiest thing. But we had to just sit down and crank a whole lot out. There was a point about halfway through development where we ended a meeting with just making a list of here's 15 things we'd like to have done in the next 2 days, and we nailed just about all of that list. So
that's fantastic. So now both of you guys have competed before. So now that you've done a couple, like what have the skills that what are the skills that you have learned through the program that you see yourself using each time you're competing?
It's communication. The first thing is communication. Like if I contact my team early, as soon as I know their names, that will give us the time to be prepared. And what I learned from the um, from the boot camp, which I applied here, is how to start looking at stuff and how to understand it. That how like making a game plan first, and then like kind not just jumping into it, making a game plan and then sharing your thoughts, brainstorming it, and then coming out with a good plan which you guys can work on it.
All right, Ken?
Yep. Yes, I would. Some of the things that I've learned over these past two code gems, clarity of communication is very important, as Jill alluded to. It was very helpful that we were able to sort of get on calls and hash things out, both synchronously on the calls and asynchronously through Discord's text chat. That part was fantastic. I also appreciate that this being my second code gem, the first one was very much more of a back-end focus. It was all about having the notebook. It was all about making charts, making machine learning models, doing some very deep analysis, whereas this one felt much more like front-end development. You're trying to make something that looks nice and has functions for an end user that you have to be thinking about. And those are two very different skill sets. Ask any software developer, they'll tell you that. And so I feel a lot more like I'm just about ready to be surprised by anything.
That's good. That's good. Because
Yes.
then, once you get surprised by everything, nothing surprises you anymore.
Yes.
Yep,
So
that's true.
this web app was done with Plotly Dash, as what we were asked to as part of the problem. And that was a brand new Python library to me. We have done a lot of Python over the course of the program, so the language is familiar, but the library was new. So going from not having used that one before to being able to create this entire HTML web page with interactivity and also putting it on render and having it spin up a server that you can just click on and go to, and there's a thing there in such a short amount of time feels great.
Yes, it just increased the confidence you had, because me too, I never used Plotly before, and then when I looked the task, I was kind of like nervous. Oh my God, again, how would I achieve that? Because I was in my mind prepared that it would be some model project, but it was not. But then I kind of got so much excited looking at this project that I somehow, when we got the task, I was like, I want to get at least one graph on the dashboard. Like, how do I do it? Like, I was so excited for it. And as soon as I got the first graph, I got so much happy. Like, it just boosted my confidence. And I didn't never imagine that our dashboard would be so much interactive. But last night, I was so happy that we came up with this result when I didn't knew anything about this uh, library at all. Like, so I taught myself and then I applied it in like those 5 days. So,
Yes,
which
girl.
yeah. So I thought that I can learn anything quickly and then apply it like as I need.
Yes, that is, I think, the best takeaway to be able to walk away with for all people that are competing.
Mm-hmm.
But in general, it's the ability to learn something super new, super quick, and just in time, right? Because you never know, like Ken was saying, you never know when something's coming around the bend. So,
Yep.
Mm-hmm.
fantastic. Well, thank you guys so very much. I'm so excited to see that your expectations were outdone by your own hard work. That is really, really wonderful. And also, thank you for sharing so that our viewers at home can try out your work. That's pretty rad.
Yes,
All right,
and
that is
definitely try out the other teams' work as well if you get the chance.
for sure. Yes.
Yes.
All of our students should be able to try them out, but I don't know that a lot of the YouTube fans get a chance to. And so maybe this will be the start of something where everybody will get to try them. Oh, okay,
Oh,
we'll see. I don't know. I
I'm
don't
like,
want to.
that
Oh my
sounds fun.
gosh.
I would participate in that.
Oh my gosh. I can see all the bugs now. Okay.
Oh yeah.
I'm going to try not to panic. All right. That is team 24/7. And that is Ken Klabnik, Gio Fadu, and Tirso Paneke. Thank you guys so very much. All right, that is it for us on this code pudding. So that about wraps us up here. So for all of us at TripleTen, thank you to you at home watching the June DS code pudding and their presentations. Thank you if you're watching it back on replay later. Don't forget to either leave a comment or in the live chat or in the comment section if you are not a student of ours just yet. And then if you are a student of ours, in the Discord channel, you will see a poll after this stream and you can vote for your favorite team there. I want to remind you that all of the winners are going to be announced on June 12th in Discord and socials. And I know we talk a lot about all of the teamwork and communication that goes into participating in one of these code jams, and it takes just as much to make one of these work. So I want to say thank you to all of the people working on the back end to help make these things possible. Daniel, Camilla, Alyssa, Elena, Olivia, Dennis, Anastasia, and of course my cat Sharkbait, who really just keeps things humming. Thank you again to all of the participants. I know that this one has been a big code pudding for you guys, and I think you all smashed it out of the park. I am so impressed to see the same data set. You guys are all coming up with different visualizations and different ways to explain what to people like myself just looks like a bunch of numbers and get lost in it. So you guys are doing amazing things. Really impressed. My name is Tiffany Hall, and you can find me at Tiffany Codes on Instagram. And you could probably find my cat Sharkbait trying to get outside to chase birds, but don't let him. He's lying. Don't let him. Thank you guys so much for watching, and have a great evening.